the next type of filter is LC filter. Now see here, this is the circuit diagram of this LC filter. In this circuit diagram, this inductor L, or you can say choke L, is connected. Choke L is connected in series with the output of rectifier. Choke L or inductor L is connected in series with output of rectifier. See here, this is inductor L, and this inductor L is connected in series with the output of rectifier, and this capacitor C is connected across this load RL. So we can write here, this capacitor C is connected across the load resistance RL, and across this load resistance RL we will get the DC output voltage, that is VDC. So across this load resistance RL we will get the DC output voltage, that is VDC. So this is the construction of LC filter. Now we will see the working of LC filter. See here, as this inductor L is connected in series with the output of rectifier, what happens, this inductor offers high reactance to the AC component, and it will have a low resistance. This inductor have a low resistance to the DC component. So the inductor which is connected in series with the rectifier, when the output of rectifier is given to this inductor, then it offers high reactance to the AC component and low resistance to the DC component. That means it will oppose the AC component in a large amount, but it will not oppose the DC component. That's why it has a low resistance to DC component and high reactance to AC component. And due to this high reactance to the AC component, the amplitudes of AC components are reduced. By this inductor L, that means this choke filter L. So this is the function of this inductor or a choke filter L in this LC filter. Now we will see what is the function of the capacitor filter C here. So the function of capacitor filter C, this capacitor filter C, it offers a low reactance. To the AC component. But it offers high resistance. To the DC component. So the capacitor always offers here the low reactance to the AC component and high reactance to the DC component. Now see in this circuit diagram here, as the output of the rectifier is given here to this inductor which is in series with the output of rectifier. So this output of rectifier is what it is, a pulsating DC. That means it having amount of ripples in DC, that means the amount of AC component in DC. That's why the output of rectifier is pulsating DC. And if this output is given to this inductor, then what happens? Inductor offers high reactance to the AC component. That means it will block the AC component, but it has a low reactance or low resistance to the DC component. So because of that, the DC components, they can pass through this inductor. But what happens? There is a small amount of AC component there passes through this inductor here. So after that, there is a capacitor connected here. So capacitor offers low reactance to the AC component. That means the AC component, they can pass through this capacitor and they will go to the ground. That means as there is a low reactance to the AC component that is offered by the capacitor, because of that the AC components are bypassed by this or through this capacitor. And as this capacitor offers high resistance to the DC component, that means it will block the DC component, and those DC components then go to this or then pass through this load resistance RL, and we will get the DC output voltage across this load resistance RL. So this is how this LC filter works. Now we will see the inductive and capacitive reactance. So see here, the inductive reactance, that is the reactance offered by inductor, is given by XL is equal to 2 pi FL. So this is the reactance offered by the inductor, and the reactance offered by the capacitor is given by XC is equal to 1 divided by 2 pi F into C. So this is the formula for the reactance offered by the capacitor. Now next point in this, the ripple factor. So ripple factor of this LC filter, it decreases with ripple factor of this LC filter, it decreases with increase in the inductance L and the capacitance C. So the ripple factor of LC filter is decreases with the increase in the inductance of inductor and the capacitance of the capacitor, and this ripple factor is independent. This ripple factor is independent of the load resistance that is RL. So this ripple factor is independent of load resistance RL. Now see this waveform of this LC filter. See here, this is the rectified output here, or the output of the rectifier that has been given as the input to the filter here, and see this is the filter output. This is the filter output. You can see here the amplitudes of the AC components are reduced by the filter here, so that we will get almost constant DC output voltage across this load resistance RL. So this is the waveform here, which shows the rectifier output as well as the filter output. Next we will see the advantages of LC filter. So the first advantage of LC filter is, in this LC filter the current flows continuously, which increases the efficiency the efficiency of transformer, which increases the efficiency of transformer. The second advantage is the output. The output of this LC filter is more pure than the output of inductor filter or the capacitor filter, inductor filter or the capacitor filter. So the output of this LC filter is more pure than the output of inductor filter or the capacitor filter. That means the LC filter gives better voltage regulation, So this is the second advantage of the LC filter. Now the third advantage of LC filter is the ripple factor. The ripple factor is independent. The ripple factor is independent of the load resistance RL. So this is the third advantage of the LC filter, that is the ripple factor is independent of the load resistance. So these are the advantages of LC filter. Now we will see the disadvantages of the LC filter. So first disadvantage of LC filter is there is a large size of inductor. First disadvantage of LC filter is there is a large size of inductor. The second disadvantage is the cost is high. Cost of this LC filter is high. So this is the second disadvantage of this LC filter. Third disadvantage of the LC filter is the external field. The external field is produced. The external field is produced by the inductor. So this is the third disadvantage of the LC filter. So these are the disadvantages of LC filter. Next is the application of LC filter. The LC filter is generally used in high power rectifier. So this is the application of LC filter. So this is all about the LC filter.